noise like thunder. The rocket takes off for space. But how do we know what it's going to do? The second our rocket is out of view, with a great big noise like thunder, the rocket takes off for space. It travels so fast that it can't be seen, so we have to track it on a radar screen.
There'll be movie cameras to film the rocket flight.
There'll be TV cameras right at the launching sites. There'll be men to tell us our rocket has hurled a man-made moon that will spin and spin all around the world. With a great big noise like thunder, our rocket takes off for space. With a roar like a fire as it climbs ever high. With a great big noise like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Rocket ready for flight. Prepare for launching of satellite. Man's first step into outer space.
We're in the blockhouse, a short distance from the launching pad of the rocket. The blockhouse has concrete walls, heavy walls 10 feet thick, and a roof with reinforced concrete 27 feet thick. A few minutes ago, there was a cloud of red smoke over the blockhouse. This meant that only 20 minutes were left, and radar operators checked their electric wires just once more, as they had done many times before. Everything has been checked and rechecked so many times. Fuel, valves, electrical wiring, tracking cameras, all must be in perfect working order. In 1/2 hour from the firing, our man-made moon will be 700 miles from the launching pad and will begin to circle the Earth at an altitude of 200 miles above sea level. There's someone going to the blackboard. He writes T minus 15. That means there are just 15 seconds remaining before our rocket is fired and goes soaring into space.
10, 9, 8, 7.
Through the loudspeaker, we hear the seconds being counted off.
3, 2, 1, 0. Fire!
The rocket is rising. Slowly, slowly, balancing itself on its own exhaust blast. Now it's X plus 15 seconds, and our rocket looks like a huge silver pencil growing smaller in the sky. In the blockhouse, every man's eye is glued to the panel, watching dials and graphs that trace the rocket's flight.
Time X plus 90.
1.5 minutes since firing. In another minute, there will be no more fuel in the first stage of our rocket. It will have used up the liquid oxygen and special fuel mixture that has given our rocket its tremendous power.
Radar report, Grand Bahama. We have the rocket on our scope.
Good. Everything is going according to plan. Wait, is that a dot on our radar screen? It's growing longer. Now there are 2 dots.
Separation accomplished. Second stage in acceleration now.
The first stage of the rocket has dropped off. Soon the first stage will begin falling while the second stage carries on.
Impact computer states first stage will impact somewhere beyond Grand Bahama and will fall into the sea. Altitude over 40 miles.
The second stage of our rocket is filled with nitric acid and fuel. This gives us a powerful thrust when the motor catches fire and shoots out tremendous flames. Of course, we can't see the rocket, but we know what's happening because our radar stations down the range are reporting into us the minute that important dot appears on their radar screens.
White Sands Proving Ground, New Mexico. We've just picked up the rocket on our screen. Second stage separation accomplished.
9 minutes have gone by since the liftoff. The second stage will soon go spinning into the ocean, and our third stage will fire. It will burn for less than 60 seconds, but that's all it will need. Our speed is increasing at a very fast rate now. 10,000 miles per hour, 12,000 miles per hour. Now it's 14,000 miles per hour.
Computer reading. Third stage now at burnout. Velocity almost 4.8 miles per second.
That means our rocket is now traveling at 17,000 miles per hour. And only one more separation is needed to put the satellite into its orbit around the Earth. Now the third stage of the rocket holds the satellite, a 20-inch shell-shaped container with a thin plating of gold. Inside the shell are many tiny instruments busily at work as they record important information. And all the while, our satellite will spin around the Earth, making its journey around the world once every 90 minutes. Think of that. People all over the globe, not only in New Mexico and in Florida will see it, but people in Spain and in India and in Tokyo, Japan. They'll see the satellite too. And all the while, the little gold ball with cameras and instruments inside will be taking pictures and measuring the weather in space, the radiation, and the millions of things that scientists have to know before it would be safe to send a man into outer space. Just a minute. I think we've got another report on the radio.
Australia tracking station. We picked up your satellite, America. Jolly good show.
Person number 3 to follow the Americans.
Our satellite is expected to orbit the Earth for a few weeks. It will carry a retro rocket to break it out of its orbit, and at a certain height will parachute slowly to Earth. In this way, we will recover the satellite and gain valuable information which the cameras in space have been keeping for us. The important pictures that will tell us more and more about outer space. Our engineers and scientists will study these pictures before man's next flight. And there'll be many more satellites shot into orbit around the Earth, man-made moons that prepare the way for man's future journey into space.
There'll be movie cameras to film the rocket flight.
There'll be TV cameras right at the launching site. There'll be men to tell us our rocket has hurled a man-made moon that will spin and spin all around the world with a great big noise like thunder. Our rocket takes off for space with a roar like a fire as it climbs ever higher with a great big noise like 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Meet Space Pilot Jones.
He's a member of the crew with a very high IQ. He's no taller than 5 feet 10.
But he can be as small as 5'2".
Meet Space Pilot Jones. He's alert and smart and quick.
Studies his arithmetic.
He is learning astronomy.
So Pilot Jones is just the man to pick.
And though his suit will not look cute, its body will look like a barrel. Its practical design will really be just fine for the best in space apparel. Meet Space Pilot Jones. He's a member of the crew
With a very high IQ.
in a uniform made for space.
He always knows exactly what to do.
Meet Space Pilot Jones.
One day there
a city going round the earth while the earth goes around the sun.
One day there will be a little city in space.
Hope that every great nation will help us build a space station. We'll be planning it, manning it soon, our city in space.
We need 30 men in our space station crew because we've got a lot of work for them to do. Each man will be a scientist. Yes, we'll need them all on our list, with food and water and oxygen we've stored to take care of everyone aboard. But our space station won't be like the cities we know, like New York or Chicago or San Francisco, with streets and restaurants and parks and ball games. You see, there will be a lot of work to do, and we have to be careful to take along what is absolutely necessary for our work.
We'll be planning it, manning it soon, our city in space.
Is it raining in Paris? Will it be cool in New York? Are there signs of hurricanes or of winds across the seas? Or is our hurricane only a summer breeze? Farmers talk about the weather. Will there be water for their crops? Will it snow tomorrow night? Should we bundle up real tight? Let us ask the weather satellite. With a television camera taking pictures from the sky, our world will see what the weather's going to be. When the clouds begin to shape up and a storm begins to brew, our television camera can report it back to you. Is it raining in Paris? Will it be cool in New York? Will it snow tomorrow night? Should we bundle up real tight? Let us ask the weather satellite.
The story of the planets began with the sun, a very hot mass of liquid gas, too hot for anyone. Now, this was 5 billion years ago. Exactly when, we do not know. But the story of the planets really did begin from the time our very hot sun began to spin. Can you imagine a huge ball of fire so tremendous that it would take more than 1 million Earths to fill it? This is the sun, a giant ball of fire turning on its axis once every 25 days. It makes a complete turn, and it is the center of our solar system, master of the planets, the wandering stars, as the people of ancient times used to call them.
round and round, round and round the sun. The wandering stars go on a journey. Can you name them one by one? Mercury, Venus, Earth and Mars, Jupiter and Saturn and Uranus, Neptune and Pluto, the wandering stars. Round and round, round and round, round and round the sun. The wandering stars go on forever. Can you name them one by one? Mercury, Venus, Earth and Mars, Jupiter and Saturn and Uranus, Neptune and Pluto, the wandering stars.
Each planet follows its course around the sun, and this is called an orbit. And while each planet travels in its orbit, it spins on its own axis. Far away through the magic distance of space are the stars. If the whole solar system could be changed into a toy model with the sun only the size of a tennis ball, you would have to walk just about 1,100 miles to the nearest star. The planet nearest to the sun is Mercury. The one furthest away is Pluto. Is Pluto the last of the planets? Are there other planets further out, even beyond our own solar system? Are there other Earths with living, intelligent beings? Other suns? Other solar systems? The answer is yes, and they are billions and billions of miles from the last of our known planets. Somewhere out in space there may be other worlds, worlds the Earthman may never see even millions of years from today, as he gazes upon the universe and dreams of visiting the planets, the wanderers in space.
Mercury, Venus, Earth and Mars, Jupiter and Saturn and Uranus, Neptune and Pluto, the wandering stars. See a big TV show from the sky, from 20,000 miles above the ground. We'll hear the news and views from all around. Way up high there'll be a big TV show from the sky. There isn't anything that's taking place we won't be hearing of from outer space. A great event,
The president,
the crowning of a king. A scientist who heads the list will see most everything. Some fine day we'll see a big TV show from the sky. You know the telephone and radio can tell us all the things we want to know. A new invention receives attention, a deed that's noble. The news is global as every day goes by. Oh, what fun to go to a TV show, the big TV show from the sky.
Ever since man looked up at the sky and saw the moon, he became curious. What was it like up there? Did people live on the moon? There were some men who actually tried to reach the moon, and many strange stories have been told about those fantastic adventures. Now, if man could build a rocket ship fast enough and strong enough to make the trip, he could travel through space to every place. Man wondered about this for years and years. We've told you something about the first space engineers, but in order to make the moon journey, first of all, we have to know how far away the moon is from the Earth.
50 round trips to California from the city of New York is the distance to the moon. We'll go there pretty soon. At 7 miles a second, 7 miles a second. Our rocket ship will make the trip in 7 miles a second. 50 round trips to California.
If we travel along the road in a car that has the power of 60 miles an hour, not
7 miles a second, 7 miles a second. Our rocket ship will make the trip in 7 miles a second. 50 round trips to California. But there's one thing we should know, that with gravity around, our car can't leave the ground.
But for the purposes of space travel, our rocket trajectory would have to attain an escape velocity of 25,000 miles an hour, which is
7 miles a second, 7 miles a second. Our rocket ship will make the trip in 7 miles a second. Now very, very soon, we're going to the moon, and the distance we found out is somewhere almost just about 50 round trips, 50 round trips, 50 round trips to California. Put a penny in the scale and weigh yourself on the planet Earth. If you weigh 102, why this is what your weight is worth on a penny scale on the planet Earth.
put a penny in the scale and weigh yourself on the planet Mars. You will weigh just 38 pounds. And just in case you've never heard, on the planet Mars, you will weigh 1/3.
The bigger the planet, the more you will weigh. The bigger the planet, the more you will weigh. That's the rule for you and me.
That's the law of gravity. Put a penny in the scale and weigh yourself on old Jupiter. You will weigh 252, for a scale on Jupiter is such. You will weigh just twice and a half as much.
Put a penny in the scale and weigh yourself on a station out in space. You will weigh just nothing at all, for that is what your weight is worth on a penny scale. High above the earth. Oh, the smaller the planet, the less you will weigh.
The bigger the planet, the more you will weigh.
That's the rule for you and me. That's the law of gravity.
Aboard Moonship Jupiter, man's first trip to the moon.
We're on a mountaintop near the equator where the air is very thin, high above the dense atmosphere of the Earth. Our rocket ship is being boarded now, and in a few seconds we will lift off the launching pad. Our journey to the moon will take about 4 days. We will travel at a speed of 7 miles per second, which is the speed we'll need to pull away from the Earth's gravity into outer space.
10, 9, 8, 7.
Now we're approaching 0 seconds, which is firing time.
2, 1, 0, fire!
It has taken us only 3 minutes to leave the Earth, and in 8 minutes our ship is far outside the Earth's atmosphere. Looking through the window of our rocket ship, we can see the Earth below. The sky is black, a blanket in space, with stars like jewels spread over an ebony ceiling. What wonderful things we see!
Through a window in space, was a silvery sight, an island so bright, and over there's the planet Mars, through a window in space, headed for the moon. The sky's a blanket of black, and when we look back, the earth seems like a toy balloon as we glide. There's a fabulous world in sight, and we ride through the silence of night on a rocket in space, traveling to the moon. We've made it there as we planned. Make ready to land on the moon.
Ahead is a great shining island, the moon. One side shines with great brightness from the light of the sun. But the sky isn't blue as we saw it from the Earth during the daytime. It always looked blue because the atmosphere of the Earth spread the rays of the sun across the heavens and gave it that beautiful color. But the moon has no atmosphere, and so the sky looks black. We're about to make our landing. We fire our retro rocket to resist the pull of the moon's gravity and make a safe landing. And now, as we slowly descend toward a huge crater in this dark, silent world, we know we are the first voyagers from Earth to reach the moon.
We've made it there as we planned. Make ready to land on the moon.
Here we are on the moon. We carry our oxygen tanks on our backs, and we are wearing special protective suits so that we may walk about the surface of the moon and make our observations. Let's go exploring. We see no plants or animals because there is no water or oxygen to supply them so that they may live and breathe. The color of the ground is gray, somewhat like ashes, and some parts of the moon seem to be darker than others. These dark patches were once thought to be seas. Perhaps there were seas on the moon a long, long time ago. And when we look at a map of the moon, we can locate the seas by name, just as if we were finding Texas or the Gulf of Mexico on a map of the United States. Here's one. It's called the Sea of Showers.
There's a place on the moon we call the Sea of Showers, where waves of water never fall and flowers never bloom at all. It's a place on the moon we call the Sea of Showers, as dry as the desert plains. Imagine a place where it never rains. It's a place on the moon we call the Sea of Showers.
On our visit to the moon, we learn that the Sea of Showers is really a desert plain, dry, without a drop of water. What's that ahead? A mountain? This mountain seems to be almost a mile wide. And we've read a lot about craters on the moon, shaped like big saucers for giant teacups. Some of them are bigger than one of our states in the USA. The moon travels around and around the Earth, and while it makes this journey, it also turns on its own axis. One night, we may behold a beautiful round moon, and on another night, it's a crescent-shaped moon, like a curved bow. But the moon never really changes shape. It only seems to be changing shape when we look at it on different nights. But the moon is always full and round, but we see only parts of it at a time as it spins around the Earth. That's why we have a new moon, a first quarter, a full moon, and a last quarter. Lovers gaze at the moon, and poets and composers write songs about the moon, while scientists study its course and its surfaces, and wonder about the side of the moon that they have never seen. Only one side of the moon faces the Earth. Through their telescopes, they have learned much about this side of the moon, its craters, its mountains, and its seas. And now at last, in a few short years, a great dream of mankind through the centuries will come true. We will see the day when man may set foot on the silent world of the moon, and scientists can explore the unknown side. Perhaps you will visit the moon and see many wonderful things. Now here is a name on the colorful map of the moon. It's called Rainbow Bay. Would you like to go there?
Do you know one day we will go and play in a wonderland upon the moon called Rainbow Bay? On a sunny day we'll be on our way to a fairyland upon the moon on Rainbow Bay. We can visit many places and still never see them all, with the Milky Way around us and a shower of stars for a waterfall. On a magic day we will fly away and remember all the things we found on Rainbow Bay.
Space Station reporting to planet Earth. We are about to attempt our first landing on the planet Mars. Space Station crew, attention please. Attention, Space Station crew.
We have been training for this flight for 2 years. Right now, we are orbiting the Earth at an altitude of 400 miles. The first expedition to Mars is about to take place. At 0 flight time, the rocket motor of our spaceship will start firing, and our ship will break out of orbit. 12 minutes later, we will move at 6 miles per second. You men know we have already made the first flight around the moon. Now, for the first time in man's history, we enter a new era in man's exploration of space and the planets. Before making our first landing on Mars, we will effect a landing on the minor planet Eros, which is 3/4 of the way to our final destination. When the 2 orbits of the planets cross, we will put our spaceship into the orbit of the planet Mars, and we will coast to its terrain by way of its own gravitational pull. It will be necessary to fire retro rockets, as you know, in order to resist the gravity pull of Mars and to make a safe landing. As to Mars itself, we already know that it's a smaller world than our own planet Earth. Every day on Mars is about 1/2 hour longer than an Earth day. Just for review, let's ask our flight engineer what kind of weather we will find on Mars.
At night, the temperature would be about 75 degrees below zero. The reason for this is that the atmosphere is extremely thin. It does not offer enough protection to explorers from Earth. During the day, of course, the weather can be quite bearable. and in the early afternoon in the summer, the weather would be about 70 degrees above zero, which is a comfortable temperature. We also know there is water on Mars, because the polar ice caps have shown us that ice and snow have formed, but these begin to melt in the spring.
There are books by great scientists who write of canals on Mars. If there are canals, perhaps intelligent Martians have built them. Perhaps there is life on Mars. But we cannot explain why these canals, as they seem to us, have straight lines. They could be natural formations, or perhaps there are other causes. You men will learn the truth at last.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, fire!
With a great big noise like thunder, a rocket takes off for space. With a roar like a fire as it climbs